Okay, now we're going to try this one. Now these are both special cases of the more general. Again, we have an x squared plus bx plus c. And when this happens, our factorizations can be found if we can find, for instance, on this first one, two factors whose product is 12, which add up to 8. If we can find that, and those two numbers are part of the factorization, and in this case, we'd start with an x and an x to get the x squared, and we would want two factors that would multiply out to give us 12, positive 12, and add up to positive 8. If we run through our multiplication tables, we realize that a plus 2 and a plus 6 would do that job, and that's finished. Over here, two factors of 9, which would multiply to 9 and give us a sum of 6, would be 3 and 3. And this one is finished. Now here we have the different case where we have a 2 in the front here and a 6 over here. Notice there's no GCF on either one of these. So we will still try to attempt our binomial form, but this time we have to account for the 2 with the x squared. So we'll start with a 2x and an x. That would make the 2x squared. The 12 now, we're not going to worry about getting two factors of 12 which add up to negative 11. Two factors which is product is 12 which add up to negative 11. That doesn't work on this type where there's a 2 up in the front. In other words, that only works when there's a 1x squared in this form. So we just try whatever we can. I'm going to try, for instance, a 3 and a 4, because I know 3 times 4 is 12. Now, since they're both the same sign, they need to both be the same sign to produce a positive. But there's a negative in the middle here, so I'm going to go with two negatives to introduce a negative into this product. It'll show up in the middle. Now the check is to come in here and say, here's a negative 3x, and here is a negative 8x product, and that adds up to negative 11. So I got this one exactly right on the first guess, and this would be my answer then. Okay. Over here, do something similar. This time, I go with a 2x and a 3x. And the 1, I don't have a lot of choice, so I just try maybe a minus 1 and a minus 1. Both negative to produce a positive 1 and to give me a negative in the middle. Now, the check is in here and here, which is a negative 2x. And that does add up to negative 5x. So sometimes you get the answers almost immediately. Notice I chose 2 and 3 instead of 1 and 6 in here. But that is my answer. I usually pick the average size numbers as opposed to the extremes. Okay, this next one, we're going to try something a little different. We're going to modify the grouping technique for this one. Even though there are only 3 terms, we can use the grouping technique modified to get this to factor, if possible. Now, here's how it works. Initially, you look at the product of these two coefficients. And that product is a 40. And what we then do is look at that 40 and try to find, we need two factors whose product is 40 and whose sum is 22. So that might take a while to run through the possible combinations. 5 and 8 doesn't work because 5 times 8 is 40, but 5 plus 8 is 13. So then I might try 20 and 2. 20 times 2 is 40. and 20 plus 2 is 22. So this is the one that's going to work. So I come over here then, and now I write this as 5x squared plus 20x plus 2x plus 8. Okay, notice this is where I use the 20 and the 2 over here. Now I can also write this as 2x plus 20 in that reverse order, and that'll still work. My next step is that I notice now that I can group. I've got 4 terms in the first group here. First group, I can pull out a 5x, which will leave me an x plus a 4. And the second group, I can pull 2 out. That'll leave me x plus 4. Then I notice I have the common x plus 4, which I can pull out. And then what's left is the 5x and the plus 2 from here. And here it is, factored. Okay, so I was able to do this without really working using the guess and check method. So this is a little more systematic. Some students like this approach. Guess and check will work also. If you're going to do a guess and check, you would immediately start with, you try this. You would immediately start off and you'd work with a 5x and an x in order to get that 5x squared. And then you'd concentrate on the 8, and you might try a 4 and a 2, for instance. And then the check in here would reveal I use a 4x, and this would give me a 10x. That's 14x, so that really doesn't work. So then what you might try is to switch the 4 with the 2. So put the 2 over here and try the 4 here. In the middle you get a 2x, and out here you get a 20x. That does give you 22x. So this is the right combination, and I got this by guessing and checking. So you can see the two methods in comparison. You don't need to do both methods and one problem. One or the other works, and that's all you need. Now this one, this is a different type of question. Notice we only have 2 terms in each one of these. Now, if we remember, I want you to just recall, this will make more sense if you recall that whenever we multiplied a minus b times an a plus b back in chapter 5, we always ended up with a squared minus b squared, because this was called this product of the sum and difference. So I'm going in reverse here. I'm starting with a difference of, in this case, notice, 2 perfect squares in each case here. So this is only going to work if I have a perfect square minus a perfect square. But when I have that, and many problems do have this form, I can easily factor it as a product of x minus 9, in this case, and x plus 9. This one would end up as an x minus 8 and an x plus 8. And this one would end up as an x plus 4 and an x minus 4. Notice that the order of the minus and the plus does not matter. I put this one x plus 4, x minus 4. So that does not matter. This is called factoring the difference. Difference of 2 squares. That's the name of this type of process, factoring the difference of 2 squares. Special form. Now in this one we have another special form. This one's called the difference of 2 cubes. Okay, these are perfect cubes. Y cubed 27, that's a 3 cubed. So as soon as you notice that you have the difference of 2 perfect cubes, we can then think about this next form, which is not as easily arrived at as the other difference of 2 squares. So you're going to have to take my word for this, or else try a long division. But whenever we have, so we'll just put these on hold for the moment here. Well, actually, let me see. Let me get rid of that. this one, I'll leave a little bit of room for each of those. But our special form is this. If we have a cubed minus b cubed, we will end up with a minus b times a squared plus ab plus b squared. That's always the way it'll be. You can verify this with a long division if you were just divide a minus b into a cubed minus b cubed. If you did that, you would end up with this a squared plus ab plus b squared as your quotient. Anyway, we also have the sum of two cubes, which also can be factored. This one's a little different. It's a plus b and a squared minus ab plus b squared. And it can be verified using the division here, but this time dividing the a cubed plus b cubed by a plus b. Anyway, up here now we have the difference. So this one will factor as it's just a matter of identifying these perfect cubes. This will be y minus 3, and this will be y squared plus 3y plus 3 squared, which is a 9. This one would turn out to be y minus 4 and a y squared plus 4y plus 16, which is the 4 squared. This one would be y minus 10 times the y squared plus 10y plus 10 squared, which is 100. Now, whenever these are second degree trinomials here, these will not be factorable any further. You can pretty much count on that. If these are second degree trinomials in one variable, monomial variable, you shouldn't be able to do anything else with this. So you assume this is prime, these trinomials. Now this one's a little different. Notice it's x to the 4th. If you're more comfortable with this form, you can just switch these around. I like to work in descending powers myself when I factor, if I have that option. So I would switch this around, and now I would try now. This is quadratic in form, as they say, because the middle term, it's got 3 terms. The middle term has an exponent which is half of the exponent of the first term here. So this is quadratic in form, and there's a constant here. So we will try our technique to handle this type. We need 2 factors of 36. Its product is 36, which add up to negative 13. And now this first term is a little different here because I need an x squared and an x squared to make an x to the 4th. But I'll go with 9 and a 4 for my 36, both negative. Now, you might say, well, I'm done here, but then you always have to make sure that your factors are completely factored. So we notice in here we've got a couple other special forms. They're both difference of squares, aren't they? So we take this x minus 3 and x plus 3, and this one is x minus 2 and x plus 2. Now we've got a complete factorization. All primes. Okay, next one here. We've got, when you scan it, you look to see if there's any GCF. Well, there is none. But after staring at it for a little bit, you realize maybe it's the difference of cubes, and then oddly enough, it is. But you have to identify the cubes first. So whether you do this step mentally or you write it down, it's up to you. We identify this as 5 cubed, and this is 2y cubed. So we will factor it as the difference of cubes. So this will become a 5 minus 2y and a 5 squared plus 5 times 2y plus a 2y squared. Now again, you can do this in one step if you want, but I'm just showing some of the detail here. So this is actually 25 plus a 10y plus a 4y squared. That's what I meant by one step. You can go right from here to here if you want. Okay, this next one, kind of complicated looking, but first thing to check would be your GCF. See if there is one. If there is, pull it out. Okay, so I got 30, 55, and 35. I realize that there's a 5 that can come from there. And a squared b cubed, a squared b squared, looks like an a squared b is also part of that GCF. And now let's see what's left over. We have a 6, and it looks like a b squared. And we have an 11, and it looks like just a b. And we have a minus 7. Okay, so far, this is what we have. This equals this. But you have to ask yourself, is this trinomial, is this fully factored or not? We don't know, so let's try. I'll set it up like this. And notice that I bring this 5a squared b with the product here. It's part of my answer. Ultimately, it'll be part of it. Now the 6b squared, I instead of trying 6b and 1b, I would try a 2b and a 3b just to get things started. Now the 7 over here, I don't have a lot of choices. 1 and 7. It's just a matter of should I put the 1 here and the 7 here, or should I do it reverse? I don't know, so I'm going to just try a minus 1 and a plus 7. Now that's the other thing. I don't know which sign is which. This might be a plus 1. This might be a negative 7. I don't know yet till I try. So it's a guess. Now the check would be to come in here and let's see. This would be a minus 3b, and this product would be a 14b. Okay, so they add up now to an 11b, and wow, I got lucky on my first try. Because you realize I might have put the 7 here and the 1 here, and I also might have mixed up my signs, but you know, I got lucky on this one, picked the right combination the first time. That's not going to happen on every problem. I know that. I don't want you to think that that you can't do that the first time every time. You can, sometimes. So there's our answer for that one. Fully factored, completely factored with all linear factors in here. And now we're going to solve some equations. Now, what we want to notice about this is that this is important. If you have a product of two things, here we have a factor and another factor. Here's one factor, here's another factor. Now the only time you can get the product of two factors to be a 0 is if both, or one or both of those factors are 0. Think about that. If you have two numbers, whose product is 0, think about your times tables. The only way you're going to get a 0 is if one or both of these are 0. Well, we take advantage of that because we say that if that's true, then either this or this is 0, x minus 10 is 0, or x minus 5 is 0, or both. So this implies x is 10, and this implies x is 5 if you just solve this for x and solve this for x. So we have these two solutions to the original equation. Now, that was already factored. If you have an equation that looks like this, for instance, x squared plus 2x minus 8 equals 0, for instance, we would first have to factor. So you go into factoring mode here and start with an x and an x. And this time we can do the two factors of 8. Product is 8, sum is 2. You might go with a positive 4 and a negative 2 would do the job. So once you're convinced you have the right factorization, which we do here, then you can take each factor, set to 0, and solve. So we have a negative 4 and we have a positive 2. So that's our solution set, negative 4 and a 2. Okay, this next one, we have a couple things to think about here. First of all, don't try to factor until you have a 0 on one side. It's not going to help you. So get the 0 first on one side, then we can talk about factoring. So let's see, I'm going to subtract that 8 from both sides, and I'll end up with this. Subtracting an 8 from both sides puts the 8 on this side as a minus. Now I go to factor. Well, first thing I notice is that there's a GCF here, and that's what you should always notice first. It's going to make your life easier if there's any more factoring to do, any other type of factoring. So GCF first, I see that I have a 4. So that'd be a 6x squared plus 11x minus a 2. Now, at this point, you can pretty much ignore the 4 because it'll never be 0. But this factor, 6x squared plus 11x minus 2, might be 0. When is it 0? I don't know. Maybe I can factor it. Well, so this 4 over here, again, we can just divide it out. It's a constant. Constant divided out. Okay, so in other words, that becomes a 1 and that becomes a 0. Now, let's try to factor this also at this point. I'm going to go with the 2x and the 3x again. And for the minus 2 here, I might go with a 2 and a 1. And since it's negative, I'm going to have to do opposite signs. I might try this. Let's see if this works. This is a 3x in the middle and a negative 4x here. So that ends up being a negative x. Well, that's not what I want. I want an 11x in here. So I have to try something else. I might try now I can switch the 2 around here, but I don't think it's going to help me. Because if I put the 2 over here, it implies another common factor of 2. So that's not going to work. And I think I have a feel for the size of the numbers here. It's going to be hard to get that 11 using a 2 and a 3. So I might go with a 6x and a 1x in this case. And still work with the 2 and the 1. Let's see what happens with that. And again, I might go with a minus and a plus. Just random choice there. Minus plus versus plus minus. Now in here you'll have a minus x for these two, and these two give you a 12x. So that adds up to 11x, and that's actually what I need here. I need an 11x. So I've got the right factorization. Now you take each of these factors and you set them to 0 and solve. These are linear factors now, so straightforward solution. And this one, of course, is just a negative 2 by adding a negative 2 to both sides. So we have our solution then, negative 2, 1 over 6 in set form.